Sampling design is divided into two categories: the probability sampling and the non-probability sampling. Probability sampling is also known as random sampling or chance sampling. In this, sample is taken in such a manner that each and every unit of the population has an equal and positive chance of being selected. In this way, it is ensured that the sample would truly represent the overall population. Probability sampling can be achieved by random selection of the sample among all the units of the population. So, examples under probability sampling are the following: simple random, systematic random, stratified random, and cluster or multi-stage sampling. Let's talk about simple random sampling or the lottery method. Simple random sample: for this type of sampling design, each member of the population is numbered. Then a given size of the sample is drawn with the help of a random number chart. The other way is to do a lottery. So we will write all the numbers in a small uniform pieces of paper and fold it and put it in a container and take out the required lot in a random manner from the container, as is done in our children's party, for example. It is relatively simple to implement, but the final sample may miss out small subgroups. So the advantages of our simple random sampling is it will be free from bias because of course it is very random. But disadvantage is it fails or it miss out small subgroups and it's difficult to obtain due to its very randomness. So there can be freak results that can be that can be obtained from the samples using simple random sampling. So the next sampling design is called systematic random sampling. This also requires numbering the entire population. Then you will choose every nth number, say for example, every fifth or tenth number, as the case may be, is selected to constitute the sample. It is easier and more likely to represent different subgroups. The advantage of systematic random sampling is it can eliminate other sources of bias. But the disadvantage is it can introduce bias where the pattern used for the samples coincides with pattern in the population. The next one is called stratified sampling. At first, the population is divided into groups or called strata, each of which is homogeneous with respect to the given characteristic feature. From each strata, then samples are drawn at random. This is called stratified random sampling. For example, with respect to the level of socioeconomic status, the population may first be grouped into such strata as high, middle, low, and very low socioeconomic levels as per predetermined criteria, and random sample drawn from each group. The sample size for each subgroup can be fixed to get representative sample. This way, it is possible that different categories in the population are fairly represented in the sample, which could have been left out otherwise in simple random sampling. The advantage of stratified sampling is it can yield more accurate results compared with our simple random sampling. It can show different tendencies within each categories. For example, when you compare men and women. But the disadvantage, that's nothing major, then hence it can be used a lot. The next example of probability sampling design is the cluster sampling. In some cases, the selection of units may pass through various stages before you finally reach your sample of study. For this, a state, for example, may be divided into districts, districts into blocks, blocks into villages, and villages into identifiable groups of people, and then taking the random or quota sample from each group. So, for example, taking a random selection of 3 out of 15 districts of a state, 6 blocks from each selected district, and then 10 villages from each selected block, and 20 households from each selected village. This design is used for large scale service spread over large areas. So it is advantageous because it is less expensive and less time consuming than a fully random sample. It can show also regional variations because you will choose not per element but per cluster. The disadvantage is not really a genuine random sample because you have already clustered the population. It is likely to yield biased results of the survey. The next type of sampling design is the non-probability sampling, and we have four major examples under non-probability sampling. First is the convenience or accidental sampling. It is sometimes known as grab or convenience or opportunity sampling. It is a type of non-probability sampling which involves the sample being drawn from that part of the population which is close to hand. That is a sample population selected because it is readily available and convenient. The researcher using such a sample cannot scientifically make generalizations about the total population from this sample because it would not be a good representative for the population. So, for example, if the interviewer or the researcher has to conduct a survey at the shopping center early in the morning on a given day, the people that the researcher can interview would be limited to those given at that at that time, which would not represent the views of other members of society in such an area. So if the survey was to be conducted at different times of day and several times per week, there will be different results. So your convenience sampling is most useful for pilot testing or testing of your research instrument. The next example is quota sampling. Quota sampling is first segmented into mutually exclusive subgroups, just as in stratified sampling. Then judgment is used to select the subjects or unit from each segment based on a specified proportion. For example, a researcher may be told to sample 200 females and 300 males between the age of 45 and 60. In quota sampling, the selection of the sample is non-random. For example, interviewers might be tempted to interview those who look most helpful. So the problem is that these samples may be biased because not everyone gets a chance of selection. This random element is its greatest weakness, and the quota versus probability has been a matter of controversy because of the randomness element. The next example for non-probability sampling is our purposive sampling or subjective or judgment sampling. In this type, the sample is selected with definite purpose in view and the choice of the sampling units depends entirely on the discretion and judgment of the researcher. This sampling suffers from drawbacks of favoritism and nepotism depending upon the beliefs and prejudices of the investigator and does not give a representative sample of the population. This sampling is seldom used and cannot be recommended for general use since it is often biased due to element of subjectivity on the part of the researcher. The last one is called snowball sampling. Snowball sampling is a method in which a researcher identifies one member of a population of interest. For example, a sensitive population such as HIV patients. So the researcher will talk to one patient, will speak to him, then ask that person to identify others in the same population or same patient, same condition, and that the researcher might be able to speak to. This person is then asked to refer the researcher to yet another person, and so on. So this sampling technique is used against low incidence or rare population such as HIV. Sampling is a big problem in this case as the defined population from which the sample can be drawn is very sensitive or sometimes not available. Therefore, the process sampling depends on the chain system of referrals. Although small sample sizes and low costs are the clear advantages of snowball sampling, bias is one of its disadvantages. The referral names obtained from those sampled in the initial stages may be similar to those initially sampled. Therefore, the sample may not represent a cross section of the total population. It may also happen that visitors to the site or interviews may refuse to disclose the name of those whom they know. So, those are the different examples of our sampling design. Now, let's move forward to sampling size. Sampling size determination is probably one of the most important phases in sampling process. Generally, the larger the sample size, the better is the estimation. But always larger sample sizes cannot be used in view of time and budget constraints. Moreover, when a probability sample reaches a certain size, the precision of the estimator cannot be significantly increased by increasing the sample size any further. So sampling size is the compromise of our statistically desirable and what is practically feasible representative of the population. In general, it is considered that the minimum of 30 participants or 30 samples is desirable for a research to have a good confidence interval and reliability.